Okay, welcome back, folks. Today we're going to look at something called the tangent ratio. So this is the beginnings of our study of trig, and it's going to come back whether you take 20-1, 20-2, 30-1, all of those courses are going to use this base concept here. Now the important part here, like it says at the top, your calculator, it needs to be in degree mode. So most calculators come standard in degree mode, all the scientific ones, but your graphing calculator, if you're using one of these, doesn't come standard in degree mode. So if it's ever been reset, you're going to need to change it back. The way to do that, click the mode button, which is to the right of the second function key, and you're going to see a whole bunch of settings come up. The one that's automatically highlighted is radians, different type of angle measure which you use in Math 30. So you're going to scroll down to it, go over to degree and press enter. Okay, so make sure degree is highlighted instead. Once it is, you can get out of there, and now your calculator is in degree mode. For other scientific calculators, if you look on the screen, it should have a capital letter D somewhere, or say DEG, something to let you know it's in degree mode. Okay, so for your specific calculator, it might be a little different. So try to Google those instructions if you're not totally sure if it's in degree mode or not. Some of them come with a little white card in the back, and that usually has the instructions on there also. Okay, so as long as that's taken care of, your calculator, basically what it does is it stores all of the possible angles and their ratios. Okay, we're going to talk about that in a couple of minutes here. Now, if we can determine the ratio, essentially what that ratio is going to look like, it's going to be a fraction. If we can find that, our calculator is going to be able to take that fraction and translate it into an angle for us. Okay, by doing that, we need to basically figure out side lengths and the relationship between them. So we've got to make sure we can label our triangle first to use the correct ratio. So there's going to be three that we look at in Math 10. First one is called tangent. Now in that box, it gives you all of the important stuff. So if the angle in question, it could be A, it could be C, it won't ever be your right angle, but those letters could be different. Okay, so keep that in mind. We won't ever use the right angle to do this. It'll always be the other two. Okay, so if it's a right angle triangle and I know my opposite side and I know my adjacent side, 2 doesn't necessarily have to be A, but it does need to be our reference angle. Okay, that angle might change. As long as it's the reference angle we're using, this relationship will hold true. So I'm going to write it a little bit neater, a little bit more concise. So the tangent of an angle. Now that symbol is called theta. It's just a Greek letter. We use it for representing an angle when we don't know it. Essentially, it's another variable. Okay, so the tangent of theta is equal to the opposite side to theta divided by the adjacent side to theta. Okay, so this is the formula that we're going to use throughout this lesson. Okay, we're going to use that down below to help us determine the tangent of certain angles. So before we actually go find out what the angles are, we need to be able to figure out what those ratios are going to look like. So let's do that down below. We're asked for two different ones. So I've got two different angles. It could be angle D or angle F. So if we write out our formula, the tangent of the angle D is equal to the opposite side divided by the adjacent side. If we fill in what we know, we don't know the angle, okay, so leave it alone as D. The opposite side length to angle D. So this is what we looked at last time. So if I just zoom in here, angle D is down in the corner. The opposite one to it is directly across. So 3 is my opposite, which is going to make 4 my adjacent. Okay, there's our ratio. That's about all we can do at this point. Now, let's go find the exact same ratio for the other angle. So the tangent of angle F, again, same relationship, opposite over adjacent. However, now you notice that things are going to change. So if I look at angle F as my reference point, my reference angle, the one in red, its opposite side becomes 4. It's actually completely flipped. So the tangent now of angle F is going to be equal to 4. Now my adjacent side has to be the one remaining, so 3. It's essentially that fraction's reciprocal, flipped over itself. Okay, so we can try the same thing for the one next to it. So for tangent of x, tangent to z, let's use some different colors here. So the tangent of angle x is equal to the opposite side over the adjacent side. So tangent x equals opposite side to x is 6, adjacent side to x is 12 because it's not the hypotenuse. We could reduce that fraction and the tangent of x is equal to 1 over 2. If we do the same thing for the tangent, I believe that's of angle z, so tangent z, again, is opposite adjacent. So that means tangent of angle z is going to be 12 over 6. And again, you can reduce that fraction. That gives you 2, which is the reciprocal of 1/2. So that basically holds true all the time. The other two angles, if you're trying to find their tangent relationships, the ratios, one will always be the reciprocal of the other, and vice versa. It'll work that way all the time. Okay, let's use that ratio now to actually find out how big those angles are. And this is where we're going to need our calculators. Okay, so again, just make sure they are in degree mode, because if they aren't, you might see some weird numbers that don't make sense, or there might be a number that does make sense, but it won't actually be the correct number. Okay, so we're asked to determine the measure of angle G and angle J, both to the nearest tenth. Now, if we can find one of them, we can always subtract from 180 to find the other one. But for now, let's just practice using that tangent ratio to do both of them. So let's do angle G first. So the tangent of angle G, again, it's opposite divided by adjacent. So I need to find the opposite side to G, which is going to be my 4. Okay, so 4 divided by 5. Now this is essentially the ratio we came up with before. In order to actually get the angle I want, I have to do something with this tangent. Essentially, it's a function that I have to figure out what the opposite of it is. Okay, just like you learned in grade 8 when you solved equations for opposite operations, there's an opposite operation to tangent. Now on your calculators, if you can locate those trigonometry buttons, there are 3 of them. Doesn't say sin, that function actually stands for sine. It's a different trig ratio. Cosine is the one beside it. Tangent is the one we're working with. Now up above, usually in a different color, it might be hard to see on the screen, but it usually says sine to the power of -1, cosine -1, tangent -1. The ones up above are called your inverse functions. Okay, they're going to be the ones to do the opposite for us. How it's going to look on paper, essentially you're going to take the inverse of both sides. And what that's going to do is on the left, you're going to be left with just the angle you want. But on the right, we have to account for that inverse function. So we're going to take the tangent inverse of our fraction. Now you could turn that fraction into a decimal if you like. You could keep it just as a fraction and put the whole thing in your calculator. It makes no difference. Okay, so we need to get that inverse function onto our screen. So we're going to press our second key, press tangent. There it is. Inside the brackets, we're going to put our 4 over 5, and then we're going to close the bracket. Again, making sure you're in degree mode. When you press enter, the number your calculator is going to tell you will be your angle. So essentially what it does is takes that ratio between those two sides and converts it into that appropriate angle measurement. We were asked for the nearest tenth. So our nearest tenth is going to be 38.7. Since that number after it's a 5, we're going to round that 6 up to a 7. So 38.7 degrees is that measurement. Okay, we'll do the same thing for angle J. So let's pick a new color here. Let's use purple. Okay, so there's J. Opposite is going to be my 5, which means my adjacent is going to be 4. So it's just going to switch my fraction over. So tangent to J is going to be 5 over 4. Same idea. Inverse of both sides. So tangent inverse in my brackets, 5 over 4. And let's go find out what that is. So second tangent, 5 over 4. Now, if you think about this, it should give me the number that when I add those two together, I get 90. If this is a right angle triangle, or any triangle I should say, all three angles have to add up to 180. But I already know one of them is 90. That means the other two angles have to add to 90. That way when I add my other right angle in, or the only right angle in total all three give me 180. So this should be about 51 point something. Okay, and there you go. Your calculator tells you the exact same thing. So that means angle J, again to the nearest tenth, is going to be 51.3. Now, if we had two of those angles, we could have subtracted from 180 as well, and it would have given us the same thing. The decimals are going to be slightly different because we're rounding them and using those ratios for both. When I add all three together, I might not totally get 180 sometimes, depending on how you've rounded it. So just keep that in mind. You might get slightly different angle measurements. Okay, I'm going to leave the one down below. That way you can pause the video, you can try that one on your own, compare it to the answer key and see how you did. It's very much similar to the one we just did. Okay, so you can give that video a pause. You can try that one out on your own. Okay, part C, we're actually asked to do something a little different. We're asked to draw a triangle now that represents this ratio. Calculate the angle in question, so theta again, to the nearest tenth. Okay, so that variable again is the Greek letter theta. You might see another one in certain applications if there's two. Looks like this. That's phi. Okay, so theta and phi is just two Greek letters we usually use for angles. Okay, so we've got to draw a triangle. Now in trigonometry, all those triangles are going to be right angles. So draw yourself a right angle triangle. It doesn't necessarily matter how it's oriented, but let's just keep it simple. Okay, there's my right angle triangle. There's my right angle. Now, the relationship they've given us, tangent uses the opposite side and the adjacent side. So we've got to make sure we really, really are careful with which numbers go where. So tangent of theta is opposite over adjacent. We were already given a fraction, so let's use the exact same one. So opposite's going to be 5, adjacent's going to be 4. Calculate the angle theta to the nearest tenth. The thing they don't tell us is where to put theta. Now that really doesn't matter. Pick a spot for it that's free in that triangle. So you can't put it where the 90 is, choose a different place. So let's put it at the bottom. If you had chosen to put it in the other spot, it wouldn't have really made a difference. Your numbers there are just going to be switched. So the opposite side to theta is going to be that one directly across from it. That will be where our 5 goes. Our adjacent is the one we have to decide on. Now it can't go up here on the top. That's our hypotenuse spot, and it always will be because it's across from our 90. My adjacent's got to be the other one. So here's my adjacent, side of 4. Okay, we're asked to draw that triangle to represent this, which we have done. Now we have to calculate the angle to the nearest tenth. So we're told to use tangent again. So let's do just that. So tan theta is 5 over 4. In order to get rid of tangent, I have to do that inverse function once again. So theta is going to equal the inverse tangent of 5 over 4. Grab your calculator, find that inverse button. 5 over 4. We actually just did it. So the answer shouldn't change. 51.3 degrees. Okay, it is nearest tenth. There's the triangle. And we probably have it up above. They are the exact same. Okay, triangles just rotated a little bit, but it is the same triangle. So essentially, if you remember, similar triangles are congruent shapes. Those are the exact same triangles, just rotated. So I know now that the other angle in here has to be the one we had above. That's going to be our 38.7. They're the exact same shape, just rotated. Okay, let's try to use this relationship now to actually find us a side length. So pretend you're given an angle. Now we got to do a little bit of manipulating to work backwards. So we're asked to determine the length of AB. So that's this side length here. Let's call it Let's just leave it as AB, to the nearest tenth of a centimeter. So here's the information I have. Now, in order to do this, labeling that triangle is going to be important. So if this is my right angle, AC is represented by, that's my hypotenuse. The other two side lengths are what we can give the name. Now, that name will come from a reference angle. So that'll be the one we use in this question. They've given me an angle of 30, so let's use 30. I could find the other angle in here, use 60 as my reference point, and switch the fraction around. It's perfectly okay to do that. The issue is if you subtract incorrectly from 180 and this angle's wrong, everything else you're going to do is also wrong. So it's a good practice to use the information they give you in the question. So let's use the 30 to do this. My opposite side to 30, it's right across from it. So there's my opposite. That's what we need to find. We're going to call it AB. Okay, the adjacent side is 10. That's what they've told us in the question. Now, since we're only using tangent, I have to have some relationship between the opposite and the adjacent. So if we just write out our formula first, tangent theta is opposite over adjacent. Essentially, there are three things I don't know in this formula: opposite, adjacent, angle. In order to use this, I have to have 2 out of the 3 unknowns. I've got an angle. That takes care of one of them. I know the adjacent. That takes care of another one. The only thing I don't know is the opposite side, which is what we're going to solve for. So let's fill in some information. My angle's 30. That can go in. The opposite side length I don't know. Let's call it AB. Okay, so there's the side length. Underneath the adjacent, which I also know, that's 10. Okay, so there's all the information in there. Now, using the inverse function on my calculator is only helpful if I'm trying to locate an angle. In this case, since I know the angle, the inverse isn't going to help me. Now, one thing you can think about here, if you try to just press tan 30 on your calculator, this is going to give you a number. Really, there's nothing special about this. It's essentially just a number. Now, in math, any number in the world, you can take it, divide it by 1. It doesn't change the value of this. So let's try to think about that for a second. If I divide this by 1, I've got now 2 fractions that are equal to each other. You learned something a few years ago that said you could cross multiply with this. This is essentially a proportion. It's a proportional relationship. So I could multiply across, divide by the thing that's on the bottom, and it'll take me straight to my answer. If you want to write that out, what it would look like is essentially you getting rid of the fractions. If you multiplied both sides by 10, these 10s would cancel, and you're left with 10 times the tangent of 30 degrees. That's equal to AB. That's exactly what we need. This, we can put the whole thing into our calculator, and it will say 10, tan 30, put it in exactly as you wrote it. There you go. That right there is your side length. Okay, so nearest tenth of a centimeter, 5.8 is what we're looking for. Which makes sense. So it can't be bigger than 10. Can't be our hypotenuse. That wouldn't make sense. 5.8 seems reasonable. It looks shorter in the picture. Now our pictures aren't always to scale, but this seems okay. Okay, this works for us. Okay, underneath, we're asked to determine the length of xy also to the nearest tenth of a centimeter. Now, if you want to try this one on your own, just pause the video, try it out. I'm going to do this one as well. I know it's a new concept, so give it a pause, try it first based on what we just did, and then when you're ready, unpause the video and we'll go through the solution. Okay, determine the length of xy to that nearest tenth. Labeling the triangle first is often very, very helpful. Across from that right angle, there's your hypotenuse. 70 will be our reference angle for this question, so opposite to it. There's our opposite side, which we have to find, xy. The one remaining has to be our adjacent. So again, we've got a relationship between opposite, adjacent, and that's going to be tangent for us. So tan theta is opposite over adjacent. Fill in what you know. We know we have an angle of 70 as our reference angle. Opposite, we're going to call xy. And adjacent, we are going to call 5. Looks very similar to the last one. My variable that I need to find is on the top. I know everything else about this relationship. So at this point, I could divide that tan 70 by 1, because if you plug it in your calculator, again, you're just getting a number. It's nothing really special. You can do that whole cross multiply process. You can get rid of the fractions however you choose to do it. You're going to be putting into your calculator 5 tan 70 is equal to xy. So if we do 5 tan 70, again, please make sure degree mode is the one that's present, and you should get 13.7 centimeters. Okay, there we go. Right. Determine the length of EF. So we're only going to do one. I'm only going to do one of these this time. And I'll leave the other one for you. Again, you've got the answer key in that Google Classroom post. So we're asked now to determine the length of EF to the nearest tenth of a centimeter. Labeling that triangle first, and we'll see what happens. So there's my hypotenuse, because there's my right angle. 20 is our reference angle this time. So across from it, that's my opposite. This is a little change from the last one where I didn't know my opposite. This time, I don't know my adjacent. And that's going to be our E to F. Okay, our formula again, tangent theta is opposite over adjacent. So let's fill in everything. I've got an angle of 20. My opposite is 3.5. My adjacent is what I don't know. That's E to F. Slightly different because that variable is on the bottom. But again, the process is the same. Tan 20, just a number. You can divide it by 1. Now this time, if you try to rearrange, cross-multiply, whatever your preference is, you're going to follow this around a different way. So you're always going to take the two things that are diagonal that actually have numerical values. You can't start with the tan 20 and the EF because you don't know the EF. You can't multiply with something you don't know. So let's start going this way. So 3.5 times 1, you got 3.5. You're going to divide it by tangent 20. So what's going to go in your calculator is 3.5 divided by tan 20. That'll be equal to our side length that we need. And when you go to put it in your calculator, you can put it in exactly how you see it. Close that bracket up, and there you go. 9.6. Because it is nearest tenth again. Hopefully I rounded correctly. I did. 9.6, not degrees. That is centimeters. Is equal to EF. Okay, so just a little change. My variable's on the bottom. So we've got to actually divide this time to get it. Okay, I won't do B. I'll leave that one for you because you've got the answer key. So try it out, compare them, see how you did. Okay, we'll take a look at a couple of problems here. And again, I don't think I'll do all of them. There are a few. So maybe I'll just do 2 of them and leave the other 2 for you. So let's take a look at the first one. A 10-foot ladder leads against the side of a building with its base 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? It's very, very helpful to have a picture. So there's our building. Here's the ground. I do need a ladder somewhere, so let's have a blue ladder. Make sure it's straight. Okay. And we're told in the question that that ladder is 10 feet. Now, if the ladder is what's leaning against the wall, that's where my 10 feet has to go. So if you're looking at this as a triangle now, the building we're assuming is standing straight up, so 90 degrees, perpendicular with the floor. My ladder is leaning against it, that's 10 feet. Against the side of the building with its base 4 feet from the wall. So down below, the base of the ladder is the bottom part down here. So my 4 feet needs to go at the base. Now, my picture doesn't look quite to scale, but that's okay. What angle to the nearest degree does the ladder make with the ground? This is the important part. I have to make sure I'm actually finding the correct angle. If I try to find the one on the top, that's where the ladder is leaving the building. That's not what I'm actually asked for. I need the other one, the one where the ladder makes the angle with the ground. Okay, that's what I'm really trying to find. Now let's try to label this triangle using the angle I need as my reference angle. So my reference angle is going to be theta right now because I don't know it. So opposite to it is going to be my wall. The 10 feet is going to be represented by our hypotenuse. And the 4 feet, that's our adjacent. So I'm going to move this picture here. Oops. That's our adjacent. Now, we run into a little bit of an issue here. If I try to use my tangent formula at this point, tan theta is opposite over adjacent. There's a problem because I don't know theta. I don't know the opposite, but I know the adjacent. That's 2 unknowns out of the 3. I got to do something else first. I need to find that side length. So based on this right angle triangle with the wall, the ground, and the ladder, I know 2 out of the 3 sides. I can use the Pythagorean theorem to find that missing one. Then I can use it to find the angle. So this one's going to take us a little bit longer, 2 steps here. So let's go ahead and use that Pythagorean theorem first. So let's say that the opposite side squared is going to be equal to our hypotenuse squared minus our other side length, still squared. So the opposite side squared, that's going to be 100 minus 16. The opposite squared is going to be 84. When you square root both sides, your opposite side length, we're going to keep it as the exact value. We don't want to round at this point because we have to use that value again to do something. So let's leave it as the square root of 84. So you would have looked at that way back in a while ago when we did exponents and radicals. So just leave it as that square root of 84. We can use that number in our fraction. That's totally fine. Now we know how to set up our trig ratio using the opposite and the adjacent. So we're going to use tangent once again. Now the angle is what we're going to find. So tan theta equals that opposite over adjacent. So fill in what you know now. Now I know the opposite is the square root of 84. Adjacent side length is 4. Now I'm trying to locate an angle. That means I need to use the inverse function on my calculator. So you were going to say that theta is equal to the inverse tangent of our fraction, square root 84 over 4. I'm going to move some stuff here. Okay. So that means theta equals. And this is where we need our calculator to punch some stuff in. So I need an inverse function first, make sure it's tangent. Inside the brackets, we're going to put in the square root of 84. So I'm actually going to use a double bracket here because when I introduce the square root, it gives me another bracket. So let's put 84, close the bracket for underneath the square root, and then I can close the bracket for the top part. So that takes my radical. Then I should be able to divide it by 4, close that bracket. I think I'm okay. There we go. That gives me my angle. If you don't want to do it that way, you could do the square root of 84, close the bracket, divide it by 4, take the decimal equivalent of that fraction, then you can do your trig ratio, the inverse, put in what that decimal equivalent is as an answer, and hit enter. And you do get the exact same result. So regardless of which method you choose, you're going to get about 66 degrees is that angle. Double check to make sure if we were asked for a whole number or not. Usually for angles, we're going to look for the nearest whole degree. So we would round that to the nearest whole number. That's 66 degrees. Okay. I'll leave B for you guys to try. And again, you've got that answer key. So let's take a look at C. And then again, I'll leave D for you all to try. So a searchlight beam shines vertically on a cloud at a horizontal distance of 250 from the searchlight. The angle between the ground and the line of sight is 75 degrees. Determine the height of the cloud to the nearest meter. So here's my light. It's shining up, it hits a cloud. That light comes back down to 75. It reflects off of it. Okay. So essentially, that scenario with the light, the reflection, and the distance that I am away from that reflection, that creates a triangle for us. Now, the picture is kind of hard to look at. So let's just take that triangle and draw it on the outside. Okay, so there's essentially what it looks like. Just pulled off the picture a little bit. So let's go put some information on there. I'm really asked to find the height of the cloud. That's what I'm really looking for. Okay, so the height of the cloud is basically from where the light shines to the top. Okay, the straightest distance between those 2 points, that's going to be our height. Okay, so let's call that x. Actually, let's call that h for height. I'm told I have an angle of 75 degrees. My right angle is exactly where you assume it would be. That light is shining perpendicularly, straight up from the ground. I have a horizontal distance of 250 meters from the searchlight. That angle is 75. So if this is my light in the corner, the distance between the light and the angle, that's 250. Okay, so here's what I know. I know I've got an angle. I know I've got a height of 250. I know I need to find this. So here's my angle. This is going to be our reference point. We need to label that triangle. So our height, that's going to be our opposite. The 250, that's our adjacent. I have everything I need. I have 2 out of the 3 pieces. We can always find the missing one. So tan theta is opposite over adjacent. Fill in everything you know. So tangent of 75 degrees equals the opposite, which is our height, adjacent, which is 250. I can't use the inverse here because, again, I know an angle. So again, tan 75, just a number, nothing fancy about it. So you can divide it by 1. Here's where you can try to get rid of that fraction. So you can do the cross multiply method if you like, multiply both sides by 250 to get rid of that fraction. So what you're really going to put in your calculator is 250 tan 75. That'll be equal to our height. So 250 tan 75, close that bracket, and there's our height. Makes sense, clouds are pretty high up. So 933, and it does say to the nearest meter. So 933 meters is the height. Okay, if you do want to get real nice and fancy, make it look real good for us. So therefore, the height of the cloud is 933 meters. Okay, so there's some of the applications of using trigonometry to solve some problems. Again, I'm not going to do the last one here. You can try that one out. It's very similar to what we've been working on. So label that triangle, try to find some information in there, find what's missing. You have the answer that's going to be posted up in that Google Classroom for you. And that takes care of tangents. So if you were looking for some extra practice stuff, those pages follow your textbook. Textbook. So as long as you've got that with you, you're able to try some other questions out on your own as well. Okay, we'll see you next time when we look at sine and cosine, a couple of other angle relationships.